Hello. So today we're going to be talking about mixtures and separation techniques. So if we look here, I have a little graphic that you've probably seen in your chemistry classes, and we have two kinds of substances. So the first is a pure element. So we can see it's a little blurry, but it's all one kind of atom. So one atom, that would be like gold. If you've ever had a gold watch or a gold piece of jewelry or seen one, that's what that is. It's just all one kind of atom. So then if we look at the one next to it, we have what's called a compound. A compound is a pure substance. It's still one thing, but it's made up of molecules consisting of several different atoms. So we see, in this case, we have the purple atoms are connected to the green atoms, and that would be something like water. So H2O, we can have pure water, but it's an oxygen connected to two hydrogens. So that's what water looks like. So far, we have the two pure substances. But that's not usually what we have in chemistry, because those are just really easy things to get. So if we look a little more complicated, you'll get to lab and you'll see mixtures of things. So a homogeneous mixture is when everything is uniform, it's distributed, you can't see a barrier. So that would be like salt water. So salt, NaCl, plus water. If you have salt water, everything's dissolved. It's clear. You can't see the salt particles. So in this case, maybe the salt is purple and the water is green. And that would be a homogeneous mixture, same homogeneous mixture, same mixture. And that would be just something that you see if you mix something up and it dissolves really well. And you'll get that a lot in lab. A heterogeneous or heterogeneous, however you want to pronounce it, is a mixture with clearly defined barriers. So we can see here, like the purple is separated from the green. So I'm sure everybody's been to the beach and you've probably seen rocky sand. So if you had a jar and you had maybe some sand, we'll go kind of quick, and then maybe a rock. You can clearly see where the sand starts and where the rocks end. So that would be heterogeneous. Moving down, we have to, in chemistry, sometimes we don't want mixtures. Sometimes we want to separate them. So this is another graphic you might have seen. And there are a bunch of different techniques for separating mixtures, and you'll learn about all of them probably at some point throughout your chemical careers, except magnets aren't talked about all too often, but I'm sure you can all have seen on TikTok where they do the cereal and they have the magnet and they can pull the iron out of the cereal. So that's just if something's magnetic, you can separate it that way. Filtration is what we see over here on the right. So you have some filter, some membrane that something can pass through and something else can't. So just like coffee, you put the coffee grounds on top of a filter and you pour water, and the water can get through with all the flavors, but the grounds themselves can't. So that's filtration, and you're left with the filtrate down here, the liquid that went through. And moving on, you have decanting. So decanting is something that you've all probably done. But if you had like a glass and maybe, there were rocks on the bottom and you wanted those to get out, you just tip the glass over and pour out the water from the top. So that would look something like this. And all the solution on top comes out, and you're left with something in the bottom. That's another one that's very common. You probably do that one probably the most in your everyday life. Moving down the list, we have evaporation. Evaporation is if you have maybe some salt water and you heat it up and all of the liquid evaporates and all you're left with are just the solids that were originally dissolved in the liquid. Continuing to move down, we'll get centrifuge. So you've all probably heard of this or seen it or heard of centrifugal force, but a centrifuge is just a big thing and it spins. So if you cut it in half, it'll look something like this, and you have two test tubes and then a big disc, and then this spins really, really fast. So that spins really fast, and the heavier stuff goes to the bottom, and you're left with lighter stuff on top. And finally, for the last couple, these are ones you'll talk about more in organic chemistry, but chromatography is what you need to know for now is separation based on polarity. So based on what the molecule likes to stick to. And distillation is similar to evaporation, and it's separation based on boiling point. So if you have a mixture of liquids, so maybe you have water and ethanol. Ethanol has a lower boiling point, so you put it in this flask with the water, you heat it up, and at 74 degrees Celsius, the ethanol will come off the column and condense, and you're left with basically pure ethanol at the end. So hopefully that was a quick overview, and it was pretty helpful when it comes to separating mixtures.